Good afternoon, and this is a video about adding and subtracting polynomials, which will be accompanying your notes. Goal for the activity: you will complete the class notes that was given to you on a piece of paper today in class as you finished your quiz. You will need to complete the notes page, and you will need to provide answers for the questions on slides 9 through 12. Learning target: apply the commutative and associative properties so that we can add and subtract to simplify polynomial expressions. So we classify polynomials by the number of terms. Terms are separated by plus and minus signs. This you may want to highlight. This is not part of your notes, but I would highlight this part right here. So an algebraic expression, polynomial means many terms. Monomial, single term. Binomial, two terms. Notice that the first and the second term, you're separated by this minus sign. Trinomial, three terms. Again, notice second term, it has a minus sign before it, and the third term also has a minus sign before it. And again, even if one of these was a plus or both were pluses, same thing, you still need plus and minus signs to separate your three terms. Degree of a polynomial. So degree depends on the largest exponent on a variable. So for this very first case, with a constant, i.e. no variable term, degree is 0. Degree is 1 anytime you just have a plain variable, no exponent. So even though you don't see the exponent value is 1. That's a linear polynomial. Quadratic polynomial is anytime you see a variable term with an exponent of 2 as your largest exponent. That's called a quadratic. Then, if you see the number 3 as your largest exponent, that's a cubic polynomial. And then you also have degree 4, quartic. That's when the largest exponent you see in your polynomial has an exponent value of 4. Now, anytime you might see 5th degree, the exponent being 5, they're just going to call it 5th degree, 6th degree, and so on. But for the most part, I would not worry too much beyond the 4th degree, aka quartic. Now, when we add and subtract polynomials, the key for this lesson is combining like terms. Like terms. They are variable terms in an algebraic expression containing both the same variables and the same respective exponent or exponents. So we've listed 3 examples. Example 1, negative 3m and positive 12m. Second example, 6x squared, negative 5x squared. Then, same variable, same exponent. This other example, negative 8, a to the third, b to the second, and a to the third, b to the second. Even though we don't see it, the coefficient is a 1. You don't see it, but there's a 1 there. So that is for your use. So let's say if you were supposed to combine negative 8, a to the third, b squared, and a positive 1, a to the third, b squared, that would be, your result would be negative 7 a to the third, b to the second. Again, we just don't want you to forget that there is a 1 here. So then it's negative 8 plus 1. That's how we get the negative 7. What are unlike terms? Algebraic expressions containing different variable terms, or algebraic expressions that could have the same variable or variables, yet different respective exponents. So, example 1, most obvious, m and n. Yeah, they're different. But now you're wondering, what about 2a and 2a squared? Same variable, but again, no exponent here. Well, I shouldn't say that's a 0. I better be careful. Even though we don't see it, exponent here is 1, yet we have an exponent of 2 for your other term. So right away, even though we have same variable letter, different exponent. So that's why in this case, you have same variable, yet different exponents. And I should say variables because for this bottom example, same thing. 3x squared y and 3xy squared. Again, same as before. You have same variable letters, but notice x is being squared for the first term, while y is being squared for the second term. So that is why this is different. So in both cases, yeah, you have the same variables, but you have different exponents for the same variables. So that's why both of these cases are not like terms, unlike terms. Whereas this one, we obviously see different variable. I mean, that's a slam dunk. Whereas these looks like the same variable, but different exponent means unlike terms. Now, these next 4, you will probably have to complete these either on a Google form or you could write them on the back of your notes sheet. So you would have to tell us which terms are like terms. Again, I'm not going to tell you that one. Same thing with 10. For 11, you pick the unlike term. One of these does not belong. 12 is the same. One of these guys does not belong. Again, when you're adding or subtracting polynomials, the goal is to combine like terms. So here's a review of adding polynomials. Combine like terms. So that means we add coefficients. Use the sign on the left. That is key. So add coefficients. That is what you're filling into the blank. Again, like terms. Same variables. Same exponents. You are filling in those blanks onto your paper. Exponents don't change. So do not, when you combine your terms, do not add your exponents. So example 1, we get 4a to the 4th minus 3a squared plus 5a plus 8a to the 4th minus 7a. Notice 4a to the 4th, 8a to the 4th. Notice how these guys are like terms. Same variable, same exponent. As a result, 4 plus 8 is 12, but notice how a to the fourth stays a to the fourth. Don't add your exponents in this case. Otherwise, that will be a mistake waiting to happen. Now, for the second part, negative 3a squared. Notice how negative 3a squared, that's the only term with an a squared. Leave it alone, bring it on down. And then last but not least, you have a positive 5a and a negative 7a. So positive 5 to negative 7, the result is negative 2a. 5 minus 7 gives us negative 2, but the a stays the same. Do not add or subtract your exponents. We don't do that here. Just add or subtract like the coefficients, not with your like terms. So this is the horizontal way. The vertical way, you line up your like terms in a table. You can line them up in columns. So we may have seen it this way as well. Notice how we have a to the fourth as one of our columns. And we have the a squares in another column. Now notice how there was only a negative 3a squared or an a squared term in the first polynomial, yet in the second polynomial, not at all. So that's why you have the plus 0 here. This is more as a space holder so that we can differentiate so that this minus 7a, rather than saying negative 3a squared minus 7a, you're going to group this negative 7a with the 5a term over here. So again, notice how we have to line up our terms. So it was sort of like when we did our elimination method. We lined up our x's and y's. This is a similar case here. Line up your like terms. And then you just add them up going down. So 4a to the fourth plus 8a to the fourth is 12. a to the fourth, negative 3a squared, plus 0 just stays negative 3a squared. Positive 5a, negative 7a, results negative 2a. So for example 15, you can use one of the two methods shown from example 14. And again, note your like terms here, negative 3, whereas this one, negative 8x. So again, group your like terms. Section part B, everything is lined up. And it's a matter of just making sure that we are combining the coefficients. So add or subtract your coefficients. Then for part C, find the perimeter. You add all sides. Number 2, combine like terms. Those are the hints for these 3. I will let you try those on your own. We will go over these together in class on Friday. Now, for subtracting polynomials, the most important step, distribute the negative 1, then combine your like terms. So similar to adding, just add your coefficients, add your positive and negative coefficients. Again, group your like terms, Do not add or subtract exponents. So now for this example, what is the difference of negative 5b to the third plus 3b squared minus 4 and 2b to the third plus 5? Now, going back to this statement here, you distribute the negative 1. This part right here is key. You're probably wondering, where is this negative 1? I will show you. Negative 1, even though you don't see it, negative 1 is actually right here. Between the minus sign and the parentheses. This is your negative 1. This is the negative 1 part right here. I see more mistakes take place because I forget to distribute the negative 1 to both the first term and the second term. And notice on the next line how positive 2b now to the third power now becomes negative 2b to the third power. Similarly, notice how positive 5, if we multiply by negative 1, becomes negative 5. Notice how both signs changed, even though you don't see it. There's a positive with the 2b to the third power. And then multiply by negative 1, that's how we get the negative here. And then similar to the adding, combine your like terms, combine your negative 5b to the third with the negative 2b to the third, combine your, well, in this case, the 3b squared just comes down for the ride, and you combine the negative 4 with the negative 5. The result is negative 9. Now 17, slide 17, similar to before. Giving you hints, we will go over this on Friday in class. Again, for this one, 5x to the third minus 8x minus parentheses 9x squared plus 5x. Again, insert your negative 1. You need to distribute. And as a result, the next line will be 5x third power minus 8x, and then it's minus 9x to the second power minus another 5x. So notice how positive 9x squared becomes negative 9x squared. Notice how positive 5x becomes negative 5x. And then here we just combine like terms if possible. If you need to use highlighters, I'll give you a hint. There's your x to the third. Negative 8x. That's its own term. Negative 9x squared. It's its own term. And negative 5x, which is similar to negative 8x. Like terms. So that's your hints. There you go. Feel free to solve it. Now this last one, they say ax is 10y to the fourth plus 3y squared. Ax is negative 6y squared plus 3y to the fourth. And cx is negative 8y to the fourth. Find ax plus bx minus c of x. Here is where we need to be very careful. A of x, we know, is 10y to the fourth plus 3y to the second power plus, could do what we should do, parentheses around each term. So a of x is the expression 10y to the fourth plus 3y squared. B of x is parentheses 6y to the second power plus 3y to the fourth power. And minus, now this is the super, we need to be careful part. Minus, but then this is why you need parentheses, negative 8y to the fourth power. Now it goes back to this part, well, basically, these two parts are not as much of a worry. Here's some magic. However, this part is the worry, because when you do minus negative, so it's negative 1 times negative 8, what really happens to the minus negative? It becomes one big positive. So really, in the end, you will have the following. And you're probably wondering, how does minus negative just becomes positive? Everybody else. Now, of course, plus a negative just makes the term negative. And basically, your first set of parentheses go. Second parentheses, the only term that's sort of affected is the negative 6y squared. That just becomes a minus 6y squared. And then, but the last term, minus negative, is the same as a positive. This is where mistakes could happen, because so many people will just say minus 8y to the fourth, but it's really minus negative, which makes all that expression positive. So those are your hints on how to combine our like terms. Just be wary of your subtraction, especially when you're subtracting a term with a negative. And that is our goal, basically, for this lesson. Combine like terms by adding or subtracting only the coefficients. Exponents don't change. When subtracting polynomials, remember to distribute the negative 1 to each term inside parentheses. Especially be careful when the leading term, or with the leading negative sign. So the leading term has a negative sign. So this is going to be as a negative sign. So this is where we need to really be careful. Because this example, minus negative 5x plus 3 becomes positive 5x minus 3. That's just another example. Again, beware. Thank you for taking your time to watch this video. And I will be able to answer questions during Friday's class. And always remember, you can see me during learning seminar or after school, Mondays or Tuesdays, especially Tuesdays.